Hello, welcome to the video. Today I'm going to be going over some derivative rules for Calc 1, so let's get into it. Alright, so the first rule I'm going to be going over is the chain rule. So, what the chain rule does, it tells you how to differentiate a composition of functions. So what this means is if you have something like f of g of x, so you're kind of nesting one function inside the other. So what it says is if you have the derivative of f of g of x, that's going to be the derivative of f of x, so f prime of x, evaluated at g of x, and then you multiply that by the derivative of g of x. So if we're not talking f and g, if we're just talking in general, the derivative of the outside evaluated at the inside multiplied by the derivative of the inside. So now let's go on to another rule. Alright, now exponential functions. So e to the x is special because it's e to the x and functions in that family, they are special because they are equal to their own derivative. So if you differentiate e to the x, what you get is e to the x back. For a to the x, it's similar. If you differentiate a to the x, you get a to the x times the natural log of a. So if your base isn't e, then you just take that function and multiply it by the natural log of the base to get the derivative. So if, let's say, if we have e to the x, that is a base of e. So that would be e to the x times the natural log of e. But the natural log of e is just 1. So this just becomes e to the x. So usually you'll be dealing with e to the x. You won't be dealing with a to the x. But, I mean, you very well could have to differentiate a function with base that is not e, but often, most times, you're going to have a base of e. Alright, so one more derivative rule. We're not going over a lot in this video. So if you have the natural log of absolute value of x, that differentiates to 1 over x. Often you'll see that the derivative of just natural log of x without any absolute value is equal to 1 over x. Technically, this only holds for x greater than 0. This equation here holds for all x, but not 0, obviously, because both those functions are undefined. But, it depends what class you're in. Often, this will be fine, but it really just depends. But technically, the correct statement is the derivative of natural log of absolute value of x is equal to 1 over x. Alright, so now let's do some practice. So this first one is just a basic chain rule problem. So what you could do is you could take this x squared minus x plus 3 and just multiply this together 4 times, and then FOIL that out, and then use your power rule. But that is ridiculously just, it's just too much work, really. We don't need to do all that. So let's use our chain rule. So what is our inside function, first off? Well, the thing that is on the inside is this. That's the thing that's on the inside being raised to the 4th power. So if we're writing this in terms of, let's just write down our chain rule first off. So we know the derivative of f of g of x, that's equal to f prime of g of x, of g of x, multiplied by derivative of g. Okay, so let's identify our f and our g. It'll get to a point where you won't have to do this, like you'll become so familiar with the formula that you can just look at the equation and kind of just solve it without needing to look at it. But for now, since you're just getting introduced, let's do this. So our inside function, that's g of x is equal to x squared minus x plus 3. And our outside function is, because we're raising the whole thing to the fourth power, our outside function is f of x equals x to the fourth. So we're composing f of x with g of x. So our composition is f composed with g of x. That's another way you'll see that written instead of this. You'll see that in a later practice problem. So now let's apply our formula. So we need to find f prime of x. F prime of x, we can use our power rule. So that's just the derivative of x to the fourth. So we bring our exponent, our power, down to the front, and then we multiply that by x to the power minus 1, so that'd be 3. That's f prime. Now we define g prime for our formula. G prime of x, that's another power rule. So we have an x squared, that becomes 2x, because you bring down the 2, reduce the power by 1. And then minus x to the first power, that differentiates to just 1. And that plus 3, that just goes away. We differentiate it. So now, if we put this all together, we do f prime, that's 4, and then we f prime of g, so replace the x with g of x. So we're going to place this x right here with g of x. So this means instead of cubing x, we're cubing the whole g of x. So x squared minus x plus 3 gets cubed. And then we multiply the whole thing by g prime. G prime is 2x minus 1. So that is our final answer. Alright, so now this one has some natural log in it. So the derivative of natural log of absolute value of x to the fifth minus e to the x plus 1. We want to evaluate that. So our outside function, again, is this natural log here. So our f of x is natural log of absolute value x. And then our g of x is g of x equals x, keep doing that, oops, x to the fifth minus e to the x plus 1. Okay, so now what's f prime of x? Well, you remember from our formula that is when we have the absolute value, or natural log of the absolute value, that differentiates to 1 over x. Which is kind of interesting. I found that weird when I first learned that, but that's how it works out. And then g prime of x is just a simple power rule. So x to the fifth is 5, because we bring that down in front. X on the reduced power, x to the fourth. Minus e to the x, we learned, just differentiates to itself. So minus e to the x. And that 1 just goes away and you differentiate it. So now, let's put it together. This is going to be, we have our functions f and g now. Just from our formula, because this is the derivative of f of g of x, our chain rule says this is going to be f prime, evaluated at g of x, multiplied by g prime of x. So that's going to be, okay, what's our f prime? F prime is 1 over x. So instead of plugging in x to that, let's plug in g. So we would do 1 over, and then g of x. So that'd be x to the fifth minus e to the x plus 1. And we multiply by g prime. That'd be 5x to the fourth minus e to the x. So this gives us 5x to the fourth minus e to the x all over x to the fifth minus e to the x plus 1. That's our final answer. For this one, we are going to need some chain rule, but actually we're also going to need our product rule. So if you notice, we have two functions being multiplied. We have e to the x, and we have square root of x squared minus 5 being multiplied. So our product rule says if we're multiplying two functions, we're going to use f and g later. So let's call them a and b. Let's call this thing a and this thing b. So the product rules tells us that this is going to be, we just add up a times b twice, but yeah, we add up a and b twice, but for one of the terms you have a prime, and for the other term you have b prime. So that means we're going to need to know our derivative of a and b. So a is e to the x. So we want to know e to the x, the derivative of that. We can use the prime symbol or use d over dx. That's just going to be e to the x. We know that. Now the other one is the one that's a little more tricky. The square root of x squared minus 5. We can't just use a simple power rule on that. This is a composition of functions. So, if you need to be reminded, this is the same thing as the derivative. A square root is the same thing as a half power. So derivative of x squared minus 5 all to the 1/2 power. So clearly, the whole thing is being raised to the 1/2 power. So that means our outside function, f, is going to have to be, f of x equals x to the 1/2. So for our chain rule formula, when we differentiate that, we're going to need to know what f prime is. So let's just find that now. f prime of x, bring down the power, and then multiply by x to the power minus 1, so negative 1/2. That's 1/2 times 1 over square root x, so that's 1 over 2 square root x. Now, our inside function, circle that in blue, our inside function is g of x equals x squared minus 5. So this is easier. This is just, we differentiate both terms, so that'd be 2x to the first power, and that negative 5 just differentiates to 0, because it's a constant. So that's equal to 2x. Oh, forgive me, it's supposed to be g prime. Wait, oh no. Sorry. That's g of x. Our g prime is going to be 2x. Okay. So now we can actually find the derivative of this piece. See, this is a multi-step problem. So, this is going to be f prime of g of x multiplied by g prime of x. So what's our f prime? That's 1 over 2 square root x. So 1 over 2 square root, and then we plug in our g of x. So g of x is x squared minus 5, so it's going to be 1 over 2 square root x squared minus 5. Alright, perfect. Multiplied by g prime, so times 2x. So these 2's are going to cancel here. So this is going to become x over square root x squared minus 5. Alright, so now we have our derivative for b, for this second portion. So that's, we have all our pieces now. We just need to put it together. So I'm going to get rid of some of this. Just drag that off screen. Alright, and then this can just go. Okie dokie. So I'm gonna bring this over here so I have room to write my answer. This is b prime of x. Okay. So now we can put this together. So this is our a prime of x. So now we put this together. So we're adding up the terms. One of them has an a prime, one has a b prime. So that's just e to the x, and then b of x, we just keep that the same. So square root x squared minus 5. Okay. So I'm actually safe to drop those parentheses. So this is just the same thing, e to the x, square root x squared minus 5. And then the other term is going to be a of x, so that's just e to the x. And then our b prime of x is x over square root of x squared minus 5. Okay. So we have a common e to the x here, so we can pull that out from both terms. So this is going to become e to the x times square root x squared minus 5 plus x over square root x squared minus 5. And that is our final answer. Alright, so this one kind of has two parts. So we're given f of x is natural log of absolute value x plus 1, and g of x is x squared. So we want to know, what is f composed with g, whole thing prime of x, and what is g composed with f, whole thing prime of x? So the order is kind of flipped, and what we're going to see here is that these are not going to be the same thing. So unlike with multiplying, you cannot just flip the order of a composition of function and have it be the same. Alright, so this, for this first one, this is the same thing. This prime, that's just a derivative. So this is a derivative of f composed with g. F composed with g is just f of g of x. So f of g of x. So we know how to differentiate that. That's gonna be f prime. So what is our f prime? We're gonna need that for both of our formulas. So let's find that. All right. So f prime of x is the derivative of natural log of absolute value x plus 1. So now I think we might be comfortable enough with the chain rule to not need to use the rule. So what we're going to do is we're going to have the derivative of the outside function. Our outside function is the natural log of absolute value. So natural log of absolute value of x. So the derivative of that is just 1 over x. We evaluate that as the derivative of the inside. So the derivative of we evaluate that at the inside. So the inside is just x plus 1. We multiply the whole thing by the derivative of the inside. Derivative of the inside is just 1. So this is 1 over x plus 1. Okay. Great. Or what if I... Alright, so now we got our f prime. Now let's get our g prime. Well, that's really easy. That's just power rule, and we've done this before. Derivative of x squared, you should know by now that's just 2x. So g prime of x is 2x. So this is going to be f prime of g of x multiplied by g prime of x. So that's going to be 1 over, and then 1 over x plus 1, but then we evaluate that at g of x. G of x is x squared, so that we, instead of x, we plug in x squared for x. So x squared plus 1. We multiply that by the derivative of g, that's 2x. So all things said, this becomes 2x over x squared plus 1. So that is our final answer. Alright, so for this other one, we kind of just reverse the order. So we've been working with f composed with g this whole time. Now we're going to start working with, we're going to work with g composed with f. So this works kind of the opposite way. This is the derivative of g of f of x, not f of g of x. Okay, so we know the derivative of the outside. We know this. Derivative of the outside evaluated at the inside multiplied by the derivative of the inside. So the letters we use, the function names we use don't matter. It just matters what's the inside, what's the outside function. Or, yeah, what's the inside, what's the outside function. So, g prime of x, we already know that's 2x. So, 2x, and then we plug in f of x into that. So, f of x is natural log of x plus 1, or natural log of absolute value of x plus 1. So this becomes 2 natural log of absolute value x plus 1. And then we multiply by derivative of the inside. So the derivative of the inside is 1 over x plus 1. So all things told, this becomes 2 natural log of x plus 1, or natural log of absolute value x plus 1, all over x plus 1. And that is our final answer. Alright, thank you for watching. I hope that you found the video helpful and that you enjoyed it. In the next video, I'm going to be going over the trig derivatives. So, like sine, cosine, tangent. I'll have to see, but like probably some secant, cosecant, stuff like that. And also the inverse trig derivatives, and I'll do some practice problems with those. So, I hope that you found the video helpful, and have a good rest of your day.